Hello viewers, in this video we will see the solution to assignment 5 for the course Integrated Circuits and Applications. First question, consider the following circuit as shown in the figure and answer the following questions. So this is a low pass filter. So the first answer is, one second. First, for the first question, this is a first order low pass filter. So cutoff frequency Fc is equal to 1 divided by 2 pi Rc. So R and C value they are given. R and C value they are given. So R is equal to, we can see here, R is equal to 1 kilo ohms and C equal to 0.1 microfarad. So if you substitute the R and C values, you will get Fc equal to 1.59 kilohertz. Option C. Option C. Second one, the value of closed loop gain A0 is given by. So for the same first order low pass filter, so A0 closed loop gain 1 plus Rf by R1. So Rf is equal to 50k, R1 equal to 25k. So 1 plus 2 is equal to 3. So you can see here Rf. So Rf is 50, R1 equal to 25. So answer is 3. Answer is 3. Option B. Third one. So again this is a low pass, first order low pass filter. So what they are asking? They are asking R and C values, and they have given the cutoff frequency. We'll see the third one. So we know the relationship between cutoff frequency and R and C value. This is equation 1, and we assume C equal to 0.02. So all this will trial and error method we are trying. So I am assuming C equal to 0.02 microfarad. The equation 1 can be written as R equal to 1 divided by 2 pi Fc into C. Substitute the value of Fc and C. So value of Fc is 5 kilohertz and C is 0.02, 10 power 6. We will get R is equal to 1.59 kilo ohms and C is equal to 0.02 microfarad. Option A. Option A. Fourth one, the values of R1 and Rf are respectively. So again using the same formula, A0 is equal to 1 plus Rf by R1, and only for this value 75k and 25k you will get this as 1 plus this will be equal to 3, therefore 1 plus 3 is equal to 4. So this is option A. Sorry, this is option R1 and Rf. D. Option D. Option D. Option D. Next, fifth one. So they have given gain equal to 4. We will see here, fourth one. They have given gain is equal to 4. Okay. So next, fifth one. So this is another circuit. This circuit is a second order low pass filter. Second order Butterworth low pass filter, and cutoff frequency is 8 hertz. 8 hertz, not kilohertz. 8 hertz. So we'll try to. They are asking the value of R and C for the cutoff frequency Fc equal to 8. So we'll try to find the answer. So for the fifth one, so we have the same approach we will use. R is equal to 1 divided by 2 pi FCC. Assume C equal to 2.2 microfarad, and R is equal to by 8. Here Fc is equal to 8, just 8 hertz. So you will get R is equal to 9.04, which is option B. Option B. Fifth is option B. Sixth one we will see, we have to find out what is the value of R1 and RF. So for Butterworth second order filter, it is A0 is fixed, second order low pass filter. For second order, whether high pass or low pass, A0 closed loop gain is fixed, it is 1.586. So this is fixed, and we'll choose the value of R1 and RF such that this ratio is 0.586. So if we choose R1 equal to 50 and RF equal to 29.3, we get the ratio as 0.586, and if we add 1, we will get 1.586. So answer is option B. Option B. So RF by R1. So R1 is equal to 50, RF equal to 29.3. What is the option you have mentioned? R1 is equal to, sorry, A, option A. Option A. Option A. Sixth is option A. I have mentioned here wrongly, B. Option A. So it should be, see, RF equal to 29, 50, R1 equal to 20. What is the question here? R1. RF they are given. So R1 should be 50. RF by RF. Okay. Option A. Next, the expression of the transfer function h of s is, so the expression for transfer function. So h of s equal to A0. So A0 comes from here. A0 is equal to 1.586. So that is nothing but our A0. Okay, and omega c square, s square plus square root 2 omega c s plus omega c square. What is omega c here? 2 pi fc. What is fc here? Fc is they are given 8. So here omega c square is 2 pi 8 whole square. That is equal to, we will get this as 2526.62. So if you substitute these values here, you will get this as this equation. So in the numerator you will get 4000, and here you will get 2526, here you will get 71.08. So that is C. That is C. Sorry, D. Option D. Option D. Option D. So that is option D. Option D. Okay. Which of the following statement is true about the quality factor Q for a wide band pass filter? So it is eighth one. Quality factor is given by F0 by bandwidth. It is actually bandwidth. F0 is center frequency, BW is bandwidth, and Q is always less than 10 for wide band filter, wide band pass filter. So answer is C. Q is less than 10. Thank you, viewers.